Hello, Randy, K7AGE. I've been working on my BitX40, doing a little bit of transmitter work. In fact, I made a couple simple mods since the last video. I've added a toggle switch here, which is basically in parallel with the transmit with the push-to-talk button, so I can put it into transmit mode and free up a hand. And I put a little LED on here to show when it's transmitting. But I needed to look at the RF output on my oscilloscope, so I've been thinking about what to do and an easy way to do that, and maybe as an opportunity to build another little piece of test gear for the shack. And I remember that Alan, W2AEW, posted a video about 5 years ago where he built a little RF sampler, and it has two outputs. One's just an attenuated RF output tap, and the other output is a simple AM demodulator tap using a couple diodes. So I have Alan's schematic here from his video, and I've redrawn that here into my own version. So basically, the way this works is that you have a straight through path. It doesn't really matter which is input and output, it's just straight through. And the two outputs, the first one is the RF sample output, and basically here it's just a simple resistor divider with then a capacitor, so it's AC coupled going into your scope. And on this other output's an AM detector output, and basically there's a capacitor that picks off the RF, a couple 1N34A germanium diodes to rectify the RF, which would basically, with an AM transmitter or sideband, give you the audio, and then a resistor and a capacitor, and here's the output for that. Parts value for this is fairly non-critical. I have the little input capacitor. I have the 47K ohm resistor that'll be used there, and then I have a 920 ohm resistor for that position. In my junk box, I didn't have a 10 puff capacitor or a 10 picofarad capacitor, so I have a 27, so that'll do fine for that. I do have a couple 1N34A diodes, germanium diodes, and of course 1K resistors are really common. And I don't have a 1000 picofarad capacitor, but I have one that's 1570. So those are the parts I have, and that's what I'll use. So I'm going to build the probe into a Altoids can. Surprise, surprise. QRP builder's favorite little chassis. So I've mounted 4 BNC connectors, one on each end and 2 on the sides, and with the idea that I'm going to use this heavy piece of wire, and that's going to solder straight through here for the pass-through, and then I can just bridge off the pass-through wire with the components going over to the BNC connectors. So, time to warm up the soldering iron. Okay, the first thing I'm going to do is put some solder on the center pins of these BNC connectors. Heat that up and kind of fill the little area there with some solder. One done, do the other. I'm going to tin the wire, heavy duty wire. This is enamel coated wire, so I've used a utility knife and scraped the enamel off. So I'm just tinning each end here, and I'm going to tin a couple areas in the center. Okay, I'm going to get in here and see if I can get this soldered in here. Heat that up, the wire. Looks like that's taking. I can see it go from shiny to dull, so it's cooled down. And now I'll solder on the other end here. So I soldered the 2 resistors and the capacitor together by wrapping the capacitor's lead around the resistor lead. So that's ready now to install. Okay, so I've got the parts in the box. I've taken the leads of the resistors on each end and wrapped them around the wires here. So they haven't been soldered yet. And the capacitor down here, it's formed up and ready to solder there. So I'm ready to get in there with the iron. And since this is a lot of heavy soldering, fired up my little fan here so to keep me from breathing this stuff in. So let me get in here and solder this resistor. Here we go. I took that one nice. Helps tinning these wires first. And here, solder this wire. There it goes. I can see the solder flowed. And I think the resistor lead is tucked up into the center of the BNC. So a little bit of solder, and I've got that one. Okay, now for the parts for the output side. The capacitor and the two diodes mechanically are kind of like the two resistors and a capacitor over here. So the capacitor is going to come off the center, the diode, you have to pay attention to the polarities now with the black lines. So these three components will go from ground to the hot line, and then on the other side of the diode will go to the center pin of the BNC with the other capacitor and resistor to ground. Okay, I have everything mechanically installed in here. Nothing's really soldered. Here's the capacitor picking off from the RF coming in. Here's the junction of the diode to ground. The other diode going to the center pin of the BNC, and along with the resistor and the 1570 picofarad capacitor to ground. So, okay, get in here and solder this stuff up, and solder the diode junction, and solder the center pin, and solder the capacitor onto the feed-through wire. Okay, I have it all done here. Everything looks to be in good shape. So let's hook this up and do a quick test with it. Okay, let's give this a try out and see how it works. I have my BIT X40, power connected here, speaker here. Here's the RF sampler box. With the connectors on the end, it allows me just to use a male-to-male BNC adapter, so I can hook it right onto the radio. And on this end, I have a 5-watt, 50-ohm dummy load. And this port here, or that output there, is just the resistor tap off of the RF. And of course, the other one has the diode. So let's take a look at the scope here. Okay, we're looking at the resistor tap, and we see two things here. One is my voice modulation, and the other is a voice modulation is filled in with the 7 megahertz RF signal. So let's move it to the diode tap and see what it looks like next. Okay, now the scope has been moved to the detector output, and you can see the RF has been removed, and you just see my voice waveform there. So, okay, well, I guess that's a wrap. The little box seems to be doing its job. Give me a little piece of test gear here. I can look at what's happening with the BIT X40. So, thanks for watching. This is Randy, K7AGE 73.